Mr. R here. Kids, again, I'm not feeling very well, so I'm trying. So I'm just letting you know that we're going to get there. Thank goodness you can't get anything from me through the airwaves. So anyway, I'm doing the best I can here today. So I want to get back here to where we kind of left off yesterday here on weather stuff. Before we do, you'll notice behind me the map. I mentioned several weather products that are out there. This is one from AOPA. I've been an AOPA member for decades now. And this is one of the things that I spoke with you early on in the year about a student membership to AOPA. And I would really encourage you to do that if you haven't already. You can do that at no cost, but it allows you access to some of the planning tools, the flight planning tools, stuff that is on that website. One of them has to do with the weather. And a lot of times, you know, we prefer things that we know. And this was something that was introduced to me a long time ago, and they have sort of refined their weather product presentations to a point that I'm used to seeing it. And so that's kind of what, you know, kind of what we do. So I want to show you a little bit here what we're looking at. So what we're looking at right now is one of the prognostic tools that they have here, the ADDS prognostic chart. And what this is doing is that this kind of gives you sort of a surface analysis, kind of again, remember, prognostication is kind of what they expect weather to do. You know, it's a guess. But that's you know, one of the things that they offer. You can look here on this side and you can see kind of where in the next 12 hours they expect weather to be, 24 hours, 36 hours, 48 hours. And that's kind of a thing about this weather product, is that you can take a look at, for instance, one of the latest surface analysis charts, and then you can kind of guess what you think may happen, and then you can look here and kind of put your guess against the professional guessers, and to kind of see, you know, what may be coming. This is one of the things that I look at most every day, certainly as I'm looking to fly, whether it's myself or commercial. But again, this is the AOPA. You can go onto their website, you can look, and under like memberships and training or something like that, you'll find, if you look hard enough, an area where you can, as a student, get a subscription to this. So here in this next 12 hours, you can kind of see here in the Pacific Northwest that we do have a system that's up here. The one thing you can't really see is kind of what's way up here, and that's something that is useful. I'm going to see if I can kind of grab that. It's sort of a static image. It won't let me actually, you know, go out beyond the borders that they have established here. But this is going to be the next potential weather system that comes through. And what happens is that you have a low and you have a high pressure system right here. And it sort of depends on the track of this weather moving in from the Pacific Northwest. Remember that weather coming in from the Pacific Northwest has a better chance to have more water vapor in it. So the actual water vapor content of that air moving in could actually lead to more snow, more so than some of the systems that move in from Canada, because they've had a chance to kind of dry out over here, and it doesn't necessarily have as much water vapor in it, generally speaking. So with this, depending on the track, if this kind of progresses from northwest to southeast, then you know, we have a better chance of snow. If this track maintains a little bit of kind of a higher, more easterly track on it, a high pressure system like this can tend to keep that system a little bit further north. And so you may get snow here, maybe in the upper portion of Colorado, but and even Vail for that matter, that won't even, you know, Aspen may get a sprinkle. And then you have something else entirely that can happen over here on the Front Range of Colorado. So those are some things that you kind of look at. For instance, if you look here at the 24-hour, you can see that that high remains somewhat stationary here in the Four Corners area. That low pressure system has moved from here to here. Now, do they see it penetrating even any further south? Again, that high remains in the Four Corners area. And now that high kind of goes away and that low comes right here. This is going to be the trick for Aspen, is that does it get any further south? And you can have a system like this that can be a, you know, a pretty decent weather maker that, you know, 50 or 100 miles makes all the difference in whether or not there's, you know, there's any snow. Now you have a somewhat stationary front. However, you've got this cold, the cold front kind of moving in here from the north here now. So, you know, it's just going to be anybody's guess, you know, if we get any snow over the weekend. If you look at like a 16-day forecast there, some of the weather guessers are calling for 3 to 5 feet of snow in Vail, and some of the models on those, you know, that type of, you know, the European model or the you know, the GSF models, some of those are showing that Aspen doesn't get anything. And so it's crazy that you have just over the hill at Vail, you know, a forecast where they can pick up anywhere from 3 to 5 feet of snow, and then Aspen not get a flake. But that's just kind of the weird part of mountain weather. So there's a guy locally, his name is Corey, and I'm forgetting his last name here this morning. And he's one of the guys that in the next couple of weeks I want to get into the classroom. He does a lot of the weather forecasting for the ski areas as well. And I think that and I don't know this because I've not necessarily seen it. People have told me about this, that there's kind of a weather forecast thing that's on the SkiCo website or something, some type of weather there. And Corey does that because he does a lot of that local forecasting stuff here. In some parts of the country, you know, you can kind of get away with sort of this regional forecast thing, but just remember, mountain weather is unlike any other weather. It can be so incredibly localized. One valley compared to the next valley can have its own ecosystem, you know, compared to weather out on the plains or you know, some other part of the country. So it's a challenge, certainly, but that's kind of where it is. So anyway, that's one of the products there. As we kind of go along, I'll show you some different weather products that are out there also for you to look at. But this is one that I kind of sort of my go-to. So back to the text here. We finished up yesterday here at looking at a weather depiction chart. Remember, this is a snapshot of what weather is at a particular time. You can see the time and the date stamp in the lower left-hand corner of the map itself. It's going to be in the lower right-hand corner of the image that you're seeing now. And then having to look at those and you know, kind of read the tea leaves as far as what you know, what may happen from here. Because again, what this does, this just shows what's happening at this point in time. Remember, anytime you see one of these weather depiction charts, it's history. By the time you print it, by the time you click save, it's history. And so it's a thing that you can get a generalized view of what's happening now, but understand that there is always going to be some type of latency period to these types of snapshots. So just keep that in mind. We're going to look down here now at these. Remember I said that you're going to need to know what do each of these charts or each of these maps that are available to you, what information is useful to you as a pilot, and again, go back to the responsibilities that we talked about yesterday about your pre-flight planning. But if you look here, the weather depiction chart shows, and you'll see a list here. I think there are 8 bullet points, maybe 7 bullet points here, 7. You're going to need to know these because you're going to get questions on that FAA exam about, what is it that you're going to glean from a weather depiction chart. So this is going to be something that you're going to need to know. And again, it's just a memorization piece. When you look here at some of the station models, the station is going to be a reporting station primarily either at an airport or some weather reporting station. Here in Colorado, I say here in Colorado, they're in Colorado. We have weather stations that are actually sitting on some of the mountain ridges that are not necessarily associated with airports. So there are additional weather stations up here in the mountains. One of the reasons for that is, as I mentioned before, is that the weather in the mountains can be so localized that it's a thing that you kind of need those other, reporting stations there to give you a better picture of what some of the localized weather can be. So that's kind of what that station is. If you look, for instance, here at these, you can kind of tell sort of, what's happening. Sky cover, and you can see this on the weather depiction charts there. Again, if it's open like this, then your visibility here is going to be, I think it's 10 miles. I'll have to look at that again. Temperature and dew point, in this case it's showing it in Fahrenheit. If you look here, you'll see that the temperature and dew point, it's only 1 degree Fahrenheit, so you could expect here, visibility issues because it's so close together. But in this case, it's not really showing it. And again, I think this is probably just for an illustrative purpose. The weather, the wind fletchings, in this case, this wind is from the north-northwest at 15 knots. Remember, the big bar is 10. The little one here is 5. And a solid flag on that thing is 50. Sea level pressure, it gives you as 107. So in this case, it basically breaks that down to the kind of the pressure trend here is just showing that the sea level pressure is decreasing. So these are some of the things that you can look at on these symbols. Now you're going to look at a surface analysis chart. And also they call it a surface weather chart. And again, this is an overview of observed situations here on the ground. So again, this is not a prognostication, this is a weather report of what is happening here. Note the difference here. The surface analysis chart does not show cloud height or tops, nor does it show the expected movement of weather pressure systems. So again, you kind of have to know what each one of these charts actually shows. You look here again. Remember, cold front, warm front, stationary, occluded front, a trough, squall line. You can look here at the fletchings here with regards to the velocity of the winds and its either direction or vector. So here again, I'm scrolling through this and it's just not moving very fast. This is one of the surface analysis charts that you can see here. This is a snapshot of what's happening now. This is one here that shows the North American continent. It looks really, really busy, but from a forecast tool standpoint, I really like looking at this when it shows the entire continent, because Most of our winter weather comes from where? It comes from way out here in the northern Pacific. We start seeing stuff brewing out here around the Aleutian Islands, and then it starts moving this direction. And this is where forecasters can really start getting a feel for what's headed our direction. And again, in this particular case, on this illustration, you see a high pressure system down below a low pressure system here. And so from a wind standpoint, you can sort of predict those winds. You look at the various lows and highs around here, and you can see what we've talked about with regard to the weather having been in a blender with stuff. It's just really kind of amazing to me how these forecasters can actually predict what's happening here based on some of this stuff. It's just sort of beyond me, but you can see here what's happening. This again, it gets kind of busy, but the big things that we look at here as far as a predictor for what our weather is going to be like is that we look at what's happening out here in the Pacific Northwest. We look at what's happening here to the north above us. Here in a couple months, we're going to start looking at what's coming from underneath, because that's really where it's going to be making our springtime and summertime weather is kind of what comes in here from the south. So there's that. Now we're going to take another look here at the imagery. Gosh, come on, baby. Which just basically shows this smaller view here of primarily the lower 48. And we can see what's happening here. We see the highs and lows. We see the fronts. We see the visibilities at some of the reporting stations as opposed to the winds that those reporting stations are reporting. And you also see the isobar lines through here, and these isobar lines are reported in sea level pressure. Hang on here, guys. Man. Radar summary charts. This again, this is not a prognostic. This is going to be a snapshot. This is a weather report. So the radar can detect only precipitation. It cannot, it can only, God, I can't even read, guys. I'm sorry. It can detect the precipitation. It can't necessarily detect the clouds, fog, or icing conditions. You may notice, well, I'll show you this probably tomorrow, and I'll show you kind of what the difference between a radar and a sky cover snapshot looks like, because with the radar piece, you see where there is rain. That doesn't necessarily mean that rain is falling, but there's enough of that liquid moisture in the air to show that that rain is there. It doesn't necessarily mean it's falling at the time that they show the shot, but and then the cloud cover can be something that can be even different. So when we look at this, again, these maps here on the radar summary charts, they will also give you a little guide to kind of solve the puzzles of what these things are showing. You can see here that you can see these echoes here of individual cells. You can see an area of cells and even a line of cells. And again, it shows the fronts. It shows all how to read these, even some of the hurricane stuff that you'll see here. You guys can look at that. It's pretty self-explanatory. So when we look here at the radar summary, now, come on, now we got something. Okay, so with this, hang on here. I'm trying to move this map. This thing is not moving very well. So what this will do is it'll show these, again, these are actual return echoes. They're not necessarily clouds. You'll have cloud cover that'll be around these other clouds, but these are the ones that are actually returning an echo from the radar stations that have enough precipitation in there to show that it's liquid moisture that's up there. And so these are mostly chances where the rain actually may be falling, but it's not always the case. So you can see here kind of what's happening. You can see some of the winds associated with the movement here. You can also see the cloud tops. For instance, in Northeast Florida here, it's showing a cloud top here of 7,000 feet. 070 means 7,000 feet. These over here, this little cloud formation here in eastern Mississippi and western Alabama, this is going to be a cloud top of 20,000 feet. So you can see here in Louisiana, 26,000 feet, 25,000 feet. Over here in central Texas, 16,000 feet, 22,000 feet. Clouds here. Here's one here, 34,000 feet. Now you start to see these clouds with this significant vertical development. That's kind of where you might start to think, okay, this is where we're going to start seeing some of our thunderstorms. And again, you have one here, out here in southeastern Kansas at 4,000 feet. So these are just an example of what you can see here from these particular radar summary maps. I want to scroll back up here because I'm not seeing here. Yeah. Yeah, I can't move this. I don't know what's going on here this morning. It may be me. I'm going to move down here a little bit further. All right, now guys, here's where it starts getting thick. This is where we're going to start learning how to decipher a routine meteorologic report and a forecast. A METAR is a routine meteorologic report about what's happening now. A TAF, T-A-F, is a terminal aerodrome forecast. So remember, the first thing that we're covering here now are reports. What's happening now, or what has happened in the not too distant past. Okay, so we're going to start talking about this, and I'm going to give you an assignment tonight to go through and kind of look at some stuff. So we're going to get to this. So here we go. This gets into METARs. METARs, again, it's that routine meteorologic report. These are going to be reports that are primarily issued from weather stations at airports, and most of the stations, in fact, I would suspect all of the stations by now are all doing this with computer stations where it'll automatically collect the information here. Most of the METARs are issued once an hour for the reports. Depending upon the airport, the time can be different as to when this report is issued. It can be at 7 minutes until the top of the hour. It can be at 14 minutes until the top of the hour. It can be at 4 minutes. I don't even remember what I just said here. And again, if I'm yelling at you, I apologize. It's just that I can't hear anything out of my head here. So, what these are for is that these are for printed reports of what was going on at an airport at a particular time. And remember that these are updated on an hourly basis. So if we look here, they are the information that they give you in the METAR it is all given to you in a particular order. You are going to need to know the order, because the order of this information is important enough that the FAA is going to ask you questions on the order that the information is given to you, okay? So keep that in mind. When you look here, the first thing that you get is that, is it going to be a METAR? Is it going to be a special report? A special report, as you have read up here, it's going to be one of the special reports that has happened in between that hourly report that they normally do, the METARs, because conditions have changed to the point that they have thought it was best to give you another an update there as well. It'll give you the station identifier. The station identifier is going to be a 4-letter ICAO code, International Civil Aviation Organization. And so, for instance, KLAX, that's Los Angeles. KASE, that's going to be Aspen. KEGE is Eagle. KGJT is going to be Grand Junction. KMTJ, that's going to be Montrose. KGWS is Glenwood Springs. You'll get the idea about kind of what those are, but almost all of the larger airports begin with the letter K in the lower 48 states here. Not sure why they begin with K, but they do. And then they give a 3-letter identifier. In some cases, the 3-letter identifier can, it kind of makes sense as to kind of what it is. Like, for instance, Denver International Airport is KDEN, and so DEN, Denver, oh, I get it. But not all of them, are like that. MCO, KMCO, Kansas City. MCO, Kansas City. Anyway, so you get the station identifier, identifies the airport. The date and time, it's going to be, it'll show the day of the month, because they're going to assume that you know what month it actually is. So they're going to give you the day of the month, and the time is going to be represented in Zulu. So just remember, what Zulu time is. Right now in Colorado, we are 7 hours behind Greenwich, England's time. So we're 7 hours behind. In the spring, when we spring forward, we spring kind of further east. And so with that, we'll be 6 hours behind Greenwich Mean Time. That differential defines Zulu. So that's kind of what that time differential means. So there you go. Then it'll give you some form of a modifier, maybe. A lot of times it won't. In some cases, it'll tell you that it's an automated report, but now the automated reports are really the only ones that kind of ever get done, and so it's just sort of a given that it's automatically done here by an automated system. The first thing that it gives you is going to be the wind. Remember, the wind is going to be a 3-digit true direction. If it's written, it's true. If it's spoken, it's magnetic. Remember that? So it'll give you the wind. Then it gives you visibility. The visibility is reported in statute miles. The reason that it gives you that in statute miles versus nautical miles is because you're looking at what is the visibility on the ground, because at some point that's where you hope to deposit that aircraft, is on the ground. And so you as a pilot need to know what is that distance, what is the visibility distance on the ground. It also used to be that they used to have a guy that would go out there once an hour, and he'd go to a particular mark and he'd look at these stations that were marked out there out in front of him, and he'd look at the farthest one he could read, and well, guess what? That's your visibility distance. So after visibility, it'll give you weather and obstructions to visibility. So it might tell you if you do have some visibility issue, it may tell you why you have a visibility issue. Now, instead of looking out over the ground, now you're going to look up, because now it's going to give you the sky conditions. It will give you this, and this is something that you need to know over here, these bullet points. You'll have skies clear, which is just kind of like you might expect as you look up. The sky is divided into eighths or octas, and that's kind of how they view these. So they actually used to have this device that they would hold up over their heads, which would kind of show this circle, this great big circle in eighths, kind of like a big pie. And they would actually see, what portions of that pie do clouds occupy. And this is sort of how they came up with this scale. So if you have few clouds, you have somewhere between 0 and 2 of those octas that might have a cloud in it. Scattered, you might have somewhere between 3 and 4, up to half of the that pi or octas with a cloud in it. Broken, 5 to 7 of these things have clouds in them. Remember, scattered is not a ceiling. Broken is a ceiling. Scattered, it's like you can fly between these clouds. Broken, you probably can't. And so that's kind of a big thing for VFR pilots, is understanding that broken layer. Because that is a ceiling. Then you have overcast, which you have, you've got the entire 8 of 8 of those octas are covered. So that's kind of what you have. Then also you may have something here with a VV, meaning vertical visibility. So they may look up from that point and say, your vertical visibility may only be 300 feet. So that's going to be a thing that you also will receive here on these METARs. You'll get temperature and dew point. Okay, we've talked about that a lot. It will give you your altimeter setting. This is going to be an altimeter setting. It'll begin with the letter A, and then it'll give you a number, and that's what you need to dial into your altimeter to make sure that you're on the same page with the current pressure levels there at that airfield, to correctly identify your altitude in MSL, means sea level. And then you may get some other remarks. In these remarks, they're normally listing now the sea level pressure for our international brothers and sisters who are flying in there, and there may be some other stuff that goes in there as well. So let's take a look here at this first METAR, and let's talk about the way that it looks. So for instance, this part right here, this is what you're going to see as a METAR. So the METAR here is here. Remember, it's a routine meteorologic report. KFMY, that's what, FMY, I'm not sure. Fort Myers, Florida. Yes, Fort Myers, Florida. Okay. So this is kind of how it looks. So the first thing that you get here after the airport identifier is you're going to get the day, which is the 14th of the month, and the time. This is going to be at 16:47 Zulu. So at 13 minutes until the top of the hour is probably when these reports are going to be taken. So this tells you again here, the 14th day of the month at 16:47 Zulu. Now, the first thing that they're going to do is they're going to tell you the wind, right? So the winds are variable, VRB, at 5 knots. Now, variable may mean that you have winds that are just kind of breezy, but there's no real direction to it. I believe if it's 5 knots or less, you can still show a variable wind. I think if it goes over 5 knots, it has to show a wind direction with that. So Again, a little variable 5-knot wind. You can still basically just pick whatever runway that is the preferred runway for that particular airport without much ado. The next thing that you're going to get here is this 10 statute miles. That's going to be your visibility. Again, remember, that's the visibility horizontal to the ground. Then you look up sky conditions. So you have skies that are going to be clear. Now you have your temperature and your dew point. This is going to be given to you in Celsius. The temperature is 30 degrees Celsius, kind of a warm day. Dew point is 16. And so that spread is pretty far away. It's much greater than 3, so we're not going to expect any visibility issues here right now. Certainly we don't, because we see that the skies are cleared. We have 10 statute miles of visibility. Next thing that you see here is the altimeter setting. Current altimeter is 30.03. Notice it doesn't have the decimal in there, but you have to remember there is a decimal in there. So it is 30.03. Now, with that high pressure, you could also predict that, yes, you should have some better flying weather. So you have light winds here, 10 statute miles visibility, skies are cleared, big dew point spread, all of that looks good. Okay? So that's how you kind of look at a METAR. And I wish they were all that simple. Now let's take a look at this one here. Here is KMCO. I said Kansas City. MCO is Orlando. I thought Orlando was ORD. I could be wrong. Anyway, so here we have KMCO. I just really thought that Orlando was ORD. I don't know. Anyway. So here we have on the 14th of the month, 1653 Zulu, winds 230 at 6. Okay, so 230 is basically from which direction? If you said southwest, good for you. Okay, so that is the direction that they come from. Remember, if you put yourself in the center of that compass rose and you stare at where 230 is, that wind is going to be in your face. So the wind is from 230 at 6 knots. Visibility, 10 statute miles. Sky conditions, few clouds at 4,000 feet AGL. 4,000 feet AGL 040, that middle 4 means that it's 4,000 feet. If it was 004, that would mean 400 feet AGL. Okay? Temperature 27, dew point 14, altimeter 30.04. Remarks. Now you have this thing here that says A02. And the A02, it's telling you that there is a precipitation discriminator on the field. A02 is telling you that you have a precipitation discriminator on the field. Not only can it tell that there is precipitation, this particular collecting station can tell you what type of precipitation that there may be. A01 tells you that there is a precipitation detector, but it can't discriminate. It can't tell you what kind. A02 tells you that it can discriminate between the various types of precipitation. So, we can all feel better about that. It gives you the sea level pressure here. And the sea level pressure, you can see here, is that it takes away the 10. So the 10 here at sea level pressure is going to be assumed, and it gives you 170. And what you do is you pretend there is a 1017.0. Okay? So that's kind of how you sort of work that. Let me draw this up here for you just a little bit here, just so that you kind of, I don't want anybody to be unclear as to how this works. So right there, that 170 means that the 1, 0 is going to be assumed and that there is a point right there. Okay? So that's going to be 1017.0. That's kind of what that means. Then you have a very precise temperature and dew point breakdown. So the way this works is like this. Well, shoot, let me redraw that line here. Okay. When you look at this temperature, it's telling you that the temperature in Celsius is 27.2 degrees. It's also telling you that the dew point is 14.4 degrees. The 0 right here means that it is a positive number. If in that position there is a 1, that means it is a negative number. Okay, so this is our timer here right now. I want you, your assignment is to go through the rest of the examples that we have here in this book to look at these METARs, okay? Because there are some additional examples that they have. Well, there may not be that many. So I want you to look at these METARs here, and I want you to kind of decode these, okay? So this is what I'd like for you to do. And then for the class tomorrow, we're going to do a series of METARs, and we're going to just work them together as a class, okay? So that's what I want you guys to do. Have an awesome day, and I will see you guys real soon. Thanks, guys. Now I'm going to shut this off. Okay. Well, how do I do this? This is awkward. Yeah, this is just kind of nutty. Here we go. Got the connection. Now, okay.